Hey everybody. Today what we're going to go through is another way to sketch a quadratic function. You can see from the title that what we're going to focus in on is going to be when we have equations given in standard or factored forms. So what we want to do is we want to talk about a different way to go through and sketch those. Again, similar to previous conversation, I am not saying that this is the best way to go through and sketch. Rather, it is an alternate way. And I think if we can tie together all of our sketching methods, then we have a really good comprehension on our parabola. Okay, let's jump in then. So let's take a look at the equation that was given in the problem. I want to go through and I want to sketch that parabola. Y equals x squared minus 2x minus 15. Now, I want to first address one option just so we can kind of rule it out. So we can make sure that we really do see we're going to take an alternate sketching method. You could, of course, sketch this using a previous method. If you wanted to go ahead and change that equation into vertex form. That is, you could use for your minimum x equals negative b, so a positive 2 over 2a. There is your one. Find the x coordinate of your vertex, sub it in, find the y, go through and sketch using that method. You, of course, could. And what I would argue is, I think that is probably the best method. Like, I'm doing this very quickly, but now that you know that x equals 1 at your vertex, you could now sub x equals 1 back in. You get 1 minus 2 minus 15. That gives you a negative 16. So you know your vertex is at 1 negative 16, and you're off to the races. If your vertex is at 1 negative 16, then maybe it's down here somewhere. And we can already see the y-intercept from our equation. Like, I can read that because it's in standard form. So I know then that my graph has to pass through those 2 points, which means I could reflect it across, get my other points, connect them with a smooth curve. As I said, this is really sloppy, but there you go. I would maybe argue to you that is the best way to go through and graph. I don't want to talk about that today. So I'm going to get rid of all of that, and I want us to focus in on a different process. As I said, this combined with our other methods is really going to allow us to understand our parabola to its fullest. Okay, so what method am I talking about? Well, we do need 3 points in our parabola. And one of the things we can do is we can find a very important set of points. We can find our x-intercepts. So what I'm going to do is I'm going to find my x-intercepts first, and I know I can do that by setting y equal to 0. When I do that, notice what gets created. It is my quadratic equation, of which I should be really good at solving that. I'm going to look to factor, and I'm really happy that this one does factor. Of course, if it didn't factor, then we could use quadratic formula. Now we're good, and therefore I can solve, and I find that I have 2 x-intercepts, one at 5, one at negative 3. I'm going to build my graph as I go. So what I know now is out here at 5 and down here at negative 3, I have 2 points on my parabola. Like I've already taken care of 2/3 of what I needed. That can be a nice way to get your points. And x-intercepts are really important features of a graph. So that didn't cost us too much time to find those 2 points. Okay, now that I have those 2 points, what's really important is I know my axis of symmetry. Remember, my axis of symmetry has to be exactly down the middle of my graph. Exactly down the middle. As soon as I have 2 points that are across from each other, then I know smack dab down the middle is my axis of symmetry. So, because of that feature, that's what I'm going to use. Now, you're going to see me label this as an AOS. There's my axis of symmetry. I know that I can find my axis of symmetry by finding the midpoint between 2 horizontal points. So, if I add my 2 x-intercepts together and then divide by 2, I'll find my average. Well, there's my 5, subtract 3 is 2, 2 divided by 2, 1. That tells me then that x equals 1 is my axis of symmetry. What that also gives me then is the x-coordinate of my vertex. So now that I've done that, and I'm just going to shrink this down a little bit just to make a little more room, I can now sub my x equals 1 back into my original function. And you'll notice I'm doing an awful lot of what I did before. There is my vertex. And so I know my vertex is at 1, -16. I can now go ahead and I can plot that. I can see that my parabola is opening up. I can see that from my equation, and I get confirmation that if I was to connect my vertex with my x-intercepts, the only way I can do that and draw a parabola is to have it open up. Now connect everything with a smooth curve. Make sure that as you're drawing it, you do your best to make sure that it passes the vertical line test. And there we go. So that is an alternate way to get down a sketch for a parabola. You'll notice I have my 3 points labeled. I've got my vertex, and I've got 2 more points, so I get an idea of shape. You'll also notice I have the same features, really. I've got 2 points across from each other, and the most important point, my vertex. So that is a method that I want to examine today. And I think if we talk about this method, we're going to have a better understanding of our parabola. So let's make a note of what we did. Okay, I'm going to leave this up on the screen, and I want to go through and I want to talk about all of these steps, because what you have is another algorithm. This is another step-by-step process that you can follow to sketch your parabola. You'll notice what we did the first step. We found the x-intercepts. I know that I can find my x-intercepts by setting my y value equal to 0. So that's what we did. Now you have an equation that's in your background. You should be good to solve that either by factoring or quadratic formula. Once we knew our 2 points across from each other, we could then move on to step 2. Find the middle of those. So let's find our axis of symmetry. I'll use the short form AOS. We do that by finding the average of the x-intercepts, right? That's your midpoint. Okay, now what we need to find is the vertex. We're moving on to step 3. You have the x-coordinate because of the axis of symmetry, so sub it back into the function and calculate your y-coordinate. Now you can plot all 3 points, connect them with a smooth curve, and there is your parabola. Okay, that is an algorithm that I want to walk through. I'm hoping that it's very logical, and I'm hoping that you can see you have all of the tools or skills needed. They're all just review topics for us. Step 1, solve quadratic equations. That's old stuff for us now. Step 2, find a midpoint. It's a midpoint of horizontal points. That's background. Complete a table of values for 1 point. Step 3, sub a value in, background. I'm hoping that this process is very logical for you. Okay, what I want to do is I want to spend the rest of the day going through and sketching using this method. There's going to be some things that are going to pop up. They're going to allow us to have a deeper understanding of what we're doing. I think today is going to be really useful for us. Okay, let's take a look at our next problem. Now, if you look back at the title, I told you that we're going to sketch using this method when we're given it in standard form or factored form. And so I hope you notice that when I gave you the function in part A, question 2, part A, I've now given you your parabola in factored form. That's going to speed up the process quite a bit. Okay, off on the right, you're going to see me do all my algebra. I'll produce my picture on the set of axes. So let's examine our first step. For me to find my x-intercepts, I'm going to allow y to equal 0. Okay, we should be pretty good to be able to go through and deal with this. Now, because you made that purple statement that your y value is equal to 0, you did not have to write that -5 leading coefficient. You didn't need that factor of -5. If my y value equals 0, which is what my statement says, then you can divide out that -5 and you could come in just on what the purple shows. Because that now allows you to find your two x-intercepts at -1, and I should use better form there, or 3. Okay, whether you want to plot those now or not, up to you. Well, as soon as I know my 2 points across from each other, I can now find my axis of symmetry. And you're going to see me write that as a little title. I really want to make sure then that I'm stating that x equals, for my axis of symmetry, the average of those two values. So add them together, cut it in half. There is a 2 over 2, and I get 1. You'll notice by me writing that, I get x equals 1. There is the equation of my axis of symmetry, my vertical line. Now that I have that, I can sub my x equals 1 back into my original function to find the y value for my vertex. And you'll notice I just subbed in 1 wherever I saw an x, and I simplified each factor. I can now calculate that. -5 times 2 is -10. -10 times -2, there's my 20. Or maybe you go a negative times a positive times a negative is a positive. 5 times 4, I don't know how you get there. But there is our vertex, 120. Okay, this is one where now I think I would go through and I would plot everything and make sure that I get some confirmation. So I now have x-intercepts at -1 and 3. I'm trying to put those on my graph somewhat proportional. You'll notice I have no scale on my y-axis yet. So for me, I could go through and say 120 is all the way here. I don't have to worry about the fact that this is 1 unit and this is 20 units. Yes, that does not look overly proportional, but I'm on a different axis. And it's okay to have different scales on each axis. Now, when I go to connect those things, I'm taking a look at my shape. I notice that I have a negative out in front, so my parabola should be opening down. I get that confirmation on my diagram. And if I've drawn this relatively proportional, then I get a good sense of, okay, I should get a pretty steep parabola. And I will do my best to draw that symmetrically, and I'm going to make sure that it passes the vertical line test. Okay, there is me using that algorithm again to sketch my parabola. Notice, it's pretty efficient, not the most efficient maybe, but pretty efficient when given standard form or factored form. Okay, as I mentioned, I want us to get better at this. So this becomes your opportunity now to try some of these on your own. Okay, you can see the function I gave you in B, and here is your chance. Let's try to tackle this one on our own, and hopefully we can do so with some confidence, very little hesitation, and we can match up in the end. Okay, I want you to give this one a shot. Pause the video now. Okay, we're back. So my first step is to find my x-intercepts. So to find my x-intercepts, my y value equals 0. Well, I don't want to blindly copy that out because I'm going to need to try to factor it or use quadratic formula. So I'm going to take a quick peek right at the very beginning, and I'm going to see, does that factor? Okay, 2 numbers of multiply to give 2. I now have 2 numbers of multiply to give 12. Well, if I go 3 and 4, then I can get a positive 8 and a negative 3. It does factor. Nice. So if I factor that, I can put in my variables in my brackets. There we go. Pretty quickly, I can come in on my 2 roots of 3/2 or negative 4. Okay, as I said, you could plot those if you want to now, or you can wait. I'm going to wait because I'm going to find my axis of symmetry. Okay, this one might have been a little uglier just because of that fraction root, but our process is still the same. So let's see if we match up. For me to get my axis of symmetry, I need to find the average of my 2 x-intercepts. So I'm going to add them together, divide it by 2. You can see the subtraction in between because I'm adding a negative, so there's my subtract. Okay, on top, I'm going to have to get a common denominator. So I'm going to take 3/2, and I'm going to subtract 8/2. If you don't like the appearance of fractions within fractions, which I totally get, then this would be the line where I may change my divide by 2 into an old-fashioned division symbol. Now, perhaps you can already see, well, if I'm going to divide by 2, then I know that I'm going to flip and multiply. Perhaps that's where you change your divide by 2 into a multiply by 1/2. I want you to make a note. Be very careful here. Do not write this. Notice in the orange, if I was to follow BEDMAS, I have to do this operation first. And that's not what I need to do to find the average. So if you don't like the old-fashioned division symbol, to avoid having to write brackets in there and do that, I would wait until your top is 1 term. You can see that in the red. Okay, I get a negative 5/2 times 1/2, and there's my negative 5/4. There we go. Okay, I have my axis of symmetry, which also means that I have the x-coordinate on my vertex. So I'm going to sub in an x value of negative 5/4 back into my original function. I'm going to follow my advice from a previous day. Square your x, so simplify each power. So if I square my 5/4, I get 25/16. I can now multiply, and now I just need to shrink that to make sure I don't forget about my minus 12 on the end. Okay, why did I just calculate my power? Well, it's because I can cross-reduce with that leading coefficient, which is really nice. Because now when I go to simplify, I get to use eighths and not sixteenths. So I can keep my numbers a little smaller as I work. When I get my common denominator, I'm going to stop right there, because if you've worked through how to change to vertex form, if you've worked through that lesson, then you're aware of our check. And I have a little confirmation again that I can use. I can see that my second term is double my first. And they're the opposite signs, so I know that I found the correct x value of my vertex. Okay, I work my way through. Don't forget about getting your common denominator with 12. And now I got to put that stuff together. Well, 25 minus 50 is a negative 25. I got a negative and a negative, so I'm going to put together my values. 96 and 25 gets me all the way up to 121. And that, of course, is eighths. So my vertex now is at negative 5/4, negative 121 eighths. Okay, let's put this stuff together and see if we get a little confirmation. So 3/2 is a 1.5, so let's say that I call that there. Negative 4 then proportionately may be all the way out there. I see that my vertex has to be to the left a bit and down a lot. So maybe I come in here on my negative 5/4, negative 121 eighths. The only way that I can connect that stuff and get my parabola is if it opens up, and I do get some confirmation. My parabola should be opening up. So now connect them with a smooth curve. Try to make it as symmetrical as possible. Pass the vertical line test, and there we go. Okay, I am hoping that we matched up and you feel very comfortable with that one. Great. Okay, as I mentioned, I just want to spend our time today working our way through these. So let's jump in and try the next one. Okay, I think this one is going to add in a little extra wrinkle to it. So we get the opportunity to maybe steal a little problem-solving practice. I want you to try this one on your own. Okay, do it on your own. We'll come back and we'll see if we match up. So pause the video now. Okay, we're back. So I want to go through now, and I need to find my x-intercepts. So to find my x-intercept, I know my y value equals 0. I'm going to write in an extra line. I could write this in, but I would argue that's me blindly copying. Because of my purple statement, I've already said y is going to equal 0. You may not like that leading term being negative. I will tell you, I do not like that leading term being negative. It causes some extra wrinkles. Maybe it slows you down with factoring, and it'll definitely affect maybe a fraction. So my advice to you would be always divide it out. So since my purple statement was there, then I'm going to divide out that negative from every term, both sides of the equal sign. I'm only going to write the purple. I would not include the orange because it's not useful and it's not needed. So keep that in mind as you move forward. Okay, I would argue to you that that purple is probably easier to recognize. That equation, that expression in it, it is not going to factor. Two numbers to multiply to give 5 and add to give 7? Nope. And so we are going to work our way through quadratic formula. Okay, I am going to work my way through now, which says, therefore, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. There's each individual term simplified. Now I can simplify underneath my root, and there are my two x-intercepts. My root 29 is not going to reduce, so I know that that is fully simplified. Okay, here is where we are going to take an opportunity to talk about some stuff. I might argue to you, this is going to go pretty deep. However, I think what I had mentioned at the beginning of the video, this is going to give us a really well-rounded understanding of quadratic formula, of the vertex of a parabola, and therefore the whole parabola. Okay, I think this is really going to help us. I want to go through and I want to do something on my graph. So we're going to really stop for a second this whole process of sketching. And I want to examine some features that we're going to see in here. I'm going to talk about why. As I said, it might get a little deep. Hang on as best you can. My x-intercepts are going to be at 7 plus root 29 halves and 7 minus root 29 halves. Now, if I was to estimate where each of those are, because I don't need a calculator, right? It's a sketch. Root 29 would be like 5 point something, right? Root 25 is 5, root 36 is 6, 29 is somewhere between 25 and 30, 5 point something. So my first is going to end up being 7 plus 5 point something, like 5 and a bit. You see that little decimal point there? Divide by 2. So if I shrink this down a little bit, that means I get like 12 and a bit, divide by 2, which means 6 point something. So I get an idea of where that x-intercept's going to lay. Like out here at 7 plus root 29 halves. It's at like 6 point something. Well, I can do the same thing with the other one. 7 minus 5 point something. Well, then that's like a 1 point something. And now, look at my fraction. My top number is smaller than my bottom. And I know anytime I take a proper fraction, top number smaller than the bottom, I end up getting 0 point something. So that's going to put that x-intercept about there. 7 minus root 29 halves. Okay, remember, I'm not focused on the sketch. So if you're wondering, hey, why did everything get really sloppy? Just hang tight. We're going to have a conversation. Okay, I want to get rid of all of that stuff because you did not need to write any of it to do what I just did. Estimate it, you're good. Okay. The next step in our process, if we were to follow our algorithm, is going to say to find the axis of symmetry. I want to note something that is going to happen always. When I go to find my axis of symmetry, I need to add those two things together. So I need to take a 7 plus root 29 halves and add it to 7 minus root 29 halves. Okay, divided by 2. Now, I am going to switch and go against everything I just said just because of what I want to talk about. I'm going to put in the old-fashioned division symbol just so we can focus on what's inside the brackets. I want you to notice what happens because you might look at inside those brackets and go, oh, now I got to add those two things together. Oh, that's going to be work. And I'm going to argue to you, no, it's not. It will never be work. This is always going to simplify in a really nice way. First off, what I want to highlight for you, notice you already have a common denominator. And you will always have a common denominator. Because both of those values came from your solution in quadratic formula, where you always have the same denominator. It's not like the positive solution and the negative solution have different denominators. Never. So, at least some of that work is nice and easy. It's already got a common denominator. Well, now you might look at it and go, yeah, but like still, I got to add together those tops and look, there's some ugly roots up there. Oh, that's not going to be... Wait a second. Look at what your top is. I want to zero in on just the roots. You are going to take the positive of something. Notice I don't even care about the fact it's root 29. The positive of something. And now you're going to subtract that exact same thing. Always. Because where do those values come from? That part of my quadratic formula, and it's always plus or minus something. So notice that my ugly roots on top will always, always, always cancel out. So when I go through to simplify that, I just have my 7 plus my 7, which is a 14, and that is 14 halves. Look how nice that simplifies. Well, now I can even calculate that. 14 divided by 2 is 7. 7 divided by 2 is 7 halves. And I come in on the x-coordinate of my vertex pretty quickly. Okay, I want you to notice what I did and all of the stuff that will always happen. You know, very rarely in math do we get always or never cases. You know, there's usually, yeah, except for this instance. We need to take advantage of when things are always or never. So look at the way that that red cleans up. That's super useful. Okay, I hope we can put that in our back pocket. Because what I want to do is I want to examine something different. What I want to do is I want to go back to something that we had to use in this problem to get our x-intercepts, our quadratic formula. And this is something where I want to examine our quadratic formula a little closer now that we have a better idea of our parabola. To do that, I'm going to write out our quadratic formula. Okay, I want to actually write out the original. I shouldn't say the original, but the actual formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. There is our quadratic formula. That we should have in our back pocket. However, I want to do something with that quadratic formula to maybe highlight a relationship that you weren't aware of. We haven't discussed it in this course. When you take a look at your quadratic formula, what I'm going to do is I'm going to break it apart. I'm going to do something with that quadratic formula that I want to make sure you're good with. I have this plus or minus in between, which means my top is 2 terms. So I'm going to break it apart into its 2 terms. Negative b over 2a plus or minus the root of b squared minus 4ac over 2a. Now, I want you to take a moment and just make sure that you understand I didn't do something fancy here with math. Like I didn't break any rules. All I did was look at my green. Both of those fractions have common denominators. So to simplify the green, you would put them together to give you the blue. Well, all I did was take the blue and I unsimplified it. I broke apart my fraction. Okay, why did I do that? Well, I did that to highlight an expression that we have used previously in this course. Take a look at your first fraction. There's your good old negative b over 2a, which we should know is the x-coordinate of our vertex. We proved that when we went through and we completed the square. Now, when you take a look at quadratic formula, I hope it's really noticeable to you now that quadratic formula actually gives you the x-coordinate of your vertex. And then it gives you an adjustment factor. My second fraction, the one that I am now circling in red, tells me, because of the plus or minus, how I move from my vertex, from my axis of symmetry. Okay, if you're looking at it and you're going, what the heck is he talking about? Can you take a look back up at the red in the top right corner for what we did when we followed our algorithm? You found your axis of symmetry, and we did that independently, and we came up with 7 halves. Well, that's the x-coordinate of my vertex. I'm going to now zoom in on my picture, and what I'm going to do is put on my x-coordinate of my vertex. I'm going to put on my axis of symmetry, smack dab down the middle. I know that that is x equals 7 halves. I just don't know where my vertex is because I don't know how high, how low. I haven't found the y-coordinate to go along with it yet. Okay, now what I want to do is I want to look at what I'm doing on the bottom. Because I know my axis of symmetry, what I just found was how far to the right and the left I move from my axis of symmetry. That is my square root of b squared minus 4ac all over 2a. What that is if I go to the right root 29 halves or to the left root 29 halves, I get to my x-intercepts. Okay, so why am I talking to you about this? Well, it's because we can be very, very well-rounded when we work with our parabola. I want you to take a look now at the mechanical solution. I want you to look at the purple. I'm going to actually get rid of all this stuff on the bottom because I want to blow this up and make it a little easier to see. I'm going to get rid of my axis of symmetry. I'm going to keep my algebra on the top right. I'm just going to keep that there so we can get confirmation. But I want you to see what you could have come up with because we used quadratic formula. You found your two x-intercepts at 7 plus or minus root 29 halves. What you also found then was you know that your axis of symmetry is x equals 7 halves. You didn't have to do all of that algebra in the well, it's not even algebra, it's calculation. But you didn't need to do all of that work in red in the top right corner because quadratic formula gives you your x-coordinate of your vertex. So if we have that, then we could jump straight to sub x equals 7 halves back into and go right back up into your original negative, square your fraction, 49 fourths, multiply that by 7, 49 halves, minus 5, and we can skip doing that work. Now, as I mentioned previously, it cleans up fast. It's actually quite beautiful how easy and how nice that will always clean up. But it doesn't mean that we should actively seek out doing that, especially not when the answer that we're looking for is staring us straight in the face. So you can now take that blue, there's your negative 49 fourths. I'm going to get my common denominator, so double that. There's my confirmation that I am correct. Get my common denominator. Clean everything up. Negative 49 plus 98 is a positive 49. There's that half and double thing again. Subtract off 20 gets me 29 fourths. And so my vertex is at 7 halves, 29 fourths. Okay, hopefully not too bad. And that discussion that we had about everything that's nice that cleans up in the top right corner calculation, but also now a faster way for us to recognize our vertex And maybe a little bit of an eye-opener to some of the other information that we actually had in quadratic formula, we maybe just didn't know it. Okay, let's jump back into our sketch. So I'm going to blow this up a little bit. We know, again, that we've already estimated. I'm going to get 6 point something. Don't ever label it with an approximate. You always label your sketch exactly. We then found that we got 0 point something, so 7 minus root 29 halves. You now found, and I'm just going to shrink that so we can see the blue vertex, that your vertex is at 7 halves, 29 fourths. So I can label that smack dab in the middle and up a bit. 7 halves, 29 fourths. And now connect everything with a smooth curve. And there you go. Like, in fact, if you even take a look at your diagram, we do get one more, little bit of confirmation. We know we have a y-intercept at -5. If I had to take a look at my graph, yeah, that might cross at like -5. That's reasonable. Then I know I'm good. And there we go. Let me shrink all of that down, put it all on the screen. Okay, that problem had a lot to it. But as I've mentioned a number of times, I'm really hoping it gives us a well-rounded approach to our parabolas. Okay, I want to jump in and have one other conversation as we go. You'll notice I've already put in the top left corner that there is a weakness for this method of sketching. Like, I put a couple asterisks there, I put a couple question marks in there. Like, what is the weakness? I want you to go ahead and try this process in order to go through and sketch y equals x squared plus 2x plus 5. Okay? I want you to use this process to sketch that parabola. I want you to pause it. I want you to try it on your own, and then we'll come back and hopefully we can examine the weakness. Okay? Pause it now. Okay, we're back. So you started off exactly following the process to find the x-intercepts. Let's let y equal 0. And when you sub in y equals 0, you can see pretty quickly that is not going to factor. We're going to need quadratic formula. So therefore, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And pretty quickly, when that thing cleans up, you have that. Okay, we see what is staring smack dab at us. You can see that we have a negative underneath our root, and therefore, we get no solution to that. And so therefore, we have no x-intercepts, because that's what the equation was finding for us. If you can't solve the equation looking for x-intercepts, then there are no x-intercepts. Okay, I am going to do something that you should not have done, because that's the end of this method for us. There's your weakness. Okay, I want you to know that this is not a special case. Given our discussion from what we used before, you should be good that you can see the x-coordinate of your vertex. We should be okay right now that our axis of symmetry is going to be at -2/2. That's -1. So if I wanted to, I could continue on and now sub x equals -1 back into my original. And there's my 1 minus 2 plus 5. When I calculate that, that's a 4. And I get my vertex at -1, 4. Okay, I think you can now tie together everything we've been talking about. I'm going to put down a quick set of axes, and I'm now going to plot everything we found. Well, what we found was our vertex is at -1, 4, so let's just call that there. But when I look back at my original equation, I have a positive leading coefficient, so I know that my parabola opens up. Well, all I'm going to do is just connect all that stuff. And I'm hoping you can now see the weakness. When we did all the purple at the very beginning, we found that there were no x-intercepts. That's not unusual. Take a look at your parabola. Its vertex is above the x-axis, and it's opening up. Of course that parabola is not going to hit the x-axis. So what we found in purple just told us that feature. But our problem with following this algorithm is we needed 2 points across from each other to find the x or the axis of symmetry. If I don't have x-intercepts, this process isn't that useful. I hope you can recognize this is going to happen a lot. Like, what happens if I have a parabola whose vertex is below the x-axis and opens down? Well, that's never going to hit the x-axis. There would be a no solution again in quadratic formula. So it's important for us to note that this method absolutely has a weakness. It assumes that you have x-intercepts. Well, you might not know that at the very beginning. So I want to make sure that we're good in recognizing the weakness, but also we can interpret it when it happens. You just have one of the instances that I drew on your graph. We can recognize the direction of opening from the equation, so you should be able to tell which one it is. Still doesn't help us to sketch. You'd have to revert to some other information. Notice we did that over here. You would then, I don't know, say that you have a y-intercept of 5 from your equation. You could reflect it, and just notice you're now using a different method to sketch. Okay, I'm hoping that that just brings to light a weakness, and if it is something that you do encounter, which you will, you're now comfortable to interpret it. Okay, as I said at the very beginning of today, I am not saying that this is the best way to sketch at all, but it is another way to sketch. And it should help us to have a more well-rounded understanding of our quadratic functions. Okay, like normal, jump in, get some practice, be as automatic with this as you can. Best of luck.